Lesson 2.1, what we're going to be talking about is we're going to be talking about the real number line. So, in some sort of math class that you've already had, you should have talked about positive and negative numbers. What the number line does is it gives me a visual of these positive and negative numbers. We can see clearly which one's smaller, which ones are larger, okay? When we're dealing with a number line, okay, I kind of want to go over this before we get into our first example. When you're writing a number line, your number line should go from smaller numbers to larger numbers, okay? It will always go from left to right, smaller numbers to larger numbers. It's just exactly how we read. If I were to read this, I would say lesson 2.1. I read from left to right. That's exactly how your number line should be. It should never be the opposite. It should never go 2, 1, 0, negative 1, negative 2, negative 3. That's an incorrect number line, okay? Whenever you're doing number lines for my class, a lot of times teachers like your number lines to be equivalent. Like, for instance, 0 would be in the middle and it would go from negative 3 to positive 3. I don't necessarily make you do that because maybe you have to graph positive 25 and positive 37. Well, that's going to be a huge number line if you have to do an equivalent. So what I ask is that you put around 4 points on your number line if you're only graphing a few things. Like, for instance, if you were going to graph if they just said graph 25, well, you could put 23, 24, 25, 26. That way I've got numbers that are smaller than 25, numbers that are larger. I've got plenty of points. I see that you know that it goes from smaller to bigger, left to right, and that accomplishes the point of a number line without having to make a huge one, okay? So let's go ahead into example 1. What they want us to do in example 1 is they want us to graph each of these points on a number line. Now, you can use one number line for both A and B. Okay, there'll be 4 points on it because we're going to label on top of the points. So, in the first one, A, I've got negative 1 3/4 and 2.7. Anytime you have numbers that are differently written, like for instance, a fraction and a decimal, my suggestion to you is the easiest way to compare them is to either make both of them a decimal or both of them a fraction. In this case, I think it would probably be easier to make it as a decimal because what is negative 1 3/4 as a decimal? Zachary?
Negative 1.75.
Perfect. Okay, that way I can easily see the difference between the two of them. Now, on this type of problem, it doesn't necessarily matter as much as it would if you were trying to compare like 4 or 5 different numbers that were all pretty close in value, but some of them were fractions, some of them were decimals. It's easier to see the difference between them if you put them all as one. Okay, so we're just going to get in the habit of doing it. So let's put a point on the number line of each of these. So negative 1.75. We're going to go to negative 1, and then about 7/10 of the way. Now, when I actually write my number on the number line, I want to write it like it's given to me in the original problem. So I'm going to write negative 1 3/4 right here instead of negative 1.75. Because when we go to call out our answers on the homework, okay, it's going to be in the original version. So then the next number we need to put is 2.7. So I go to 2, and I go over to 0.7. Okay, so let's do points on our next thing. I'm going to erase these so I can easily see the difference. You can do them on the same number line. Our next points are negative 5 and negative 1/2. So I would go to negative 5 here. Now, in this case, you don't need to change negative 1/2 to 0.5 because there's no other decimal here that we would need to change it. It's just a whole number and then negative 1/2. So where would negative 1/2 be? William?
Between like halfway between 0 and -1.
Very good. Halfway between 0 and -1. It is not in between -1 and -2. That would be -1 and 1/2. Okay? Now, whenever you do points, I do want you to write the numbers above them so we know exactly what you're talking about. I know that that's -1/2 because I've written it above it. Somebody may come along and say, ooh, maybe is that 4/9 or is it 4/7? Like it could be something crazy like that. So you want to always assure the person who's looking at your work that this is what I meant by this point. Okay? Okay, example 2. Graph on a number line and write, okay, I'm going to change these instructions real quick. Graph on a number line and write 2 inequalities to compare. So we're going to write 2 inequalities to compare the numbers because that's what the instructions are on your homework. Okay, that's what the instructions are on your homework. And I want to go ahead and do it in the example so you know exactly what to do when you get home tonight. So what I would like you to do, instead of doing a huge number line like I've done down here, I would do 2 smaller number lines. So if you want to do maybe -2, -1, 0, and 1, and do the same thing, you can do the exact same thing for this one. We could do -2, -1, 0, and 1. So that when we go to compare them, we're not confused at why there's, more than 2 points. We can just look at those 2 points. I'm just going to use the number line that I have down here because I can erase my points. You don't want to erase yours because that's on your notes. Okay, so -3/2. That may not be the easiest point to find if I'm looking on a number line. So what could I do to -3/2 to make it easier to see, William?
You change it to 1/2.
Very good. Change it to a mixed number, which means this is how you do a mixed number. If you have forgotten or maybe you've never learned it, you would take 2 and you ask yourself, how many times can it go into 3? 1. I keep my negative sign because I know it's negative. So that becomes my whole number, 1. And then I ask myself, how many would I have left if I then subtracted those numbers? 3 minus 2 is 1. So that's my new numerator, and my denominator will always stay the same. So I have -1 and 1/2 and -1/2. And I'm going to compare these two. So first of all, I'm going to place them on the number line. -1 and 1/2 is here. And then -1/2 is here. So they want us to write 2 inequalities to model or compare the numbers. Well, when I actually go to write my final answer as with the inequalities, I want to write it exactly how the original problem was written. So I'm going to say -3/2 and -1/2. Well, when it says inequality, let's back up. What does an inequality mean? Cole?
Less than or greater than?
A greater than or less than sign. So let's ask ourselves, -3/2 is what than -1/2? Greater than or less than? Zachary?
Less than.
Less than. Perfect. So that means in order to write the other inequality, I would just say -1/2 is greater than -3/2. There are my 2 inequalities to compare. Now remember this, whenever we're dealing with negative numbers, the bigger the number is, the smaller it actually is. Okay? A negative number, the bigger it is, the smaller the value it actually has. Okay? Alright, the next time, okay, when I have these numbers, I need to compare them. So when we have these 2 numbers, all right, they want us to compare these. But these fractions are really kind of tricky to compare. Because how do I know, is 7/16 bigger or is 5/8 bigger? It's really hard to figure out. So, Nishan, do you have a tip for us?
I think 7/16 is smaller.
Okay, he thinks 7/16 is smaller. Let's test that theory. And this is how we would test it, okay? In order to compare fractions, the easiest way I can tell you to do it is get a common denominator. If you get a common denominator, it's going to become really easy because I see exactly how much it is. What is a good common denominator of 16 and 8? Zachary? 16. So I'm not going to touch the first fraction. It's fine. But the second fraction, Jarrett, what would I need to multiply by? 2. Whatever I do to the bottom, I have to do to the top. And I don't worry about the whole number. It's fine just like it is. So now I have -1 and 7/16. And I have -1 and 10 over 16. Now remember, we're dealing with negative numbers. So that means the bigger the number is, the smaller it is. So then, which one of these numbers is larger? Cole?
-1, 7.
-1 and 7/16. Okay? Do not be confused because the easiest thing to do is look at the denominators of the original 16 and 8 and say, oh, because 16 is bigger, that's what it's got to be. That's got to be the smaller one since it's negative, okay? So let's put our point on the graph. If I have -1, so I'd go from the 0 to the -1, and then I have an additional 7/16. So that's going to go maybe right about here. And then I have -1 and an additional 10/16, which may go somewhere right about here. I'm going to write the value below it. So I can see which one of these is less than the other or which one of these is greater than the other. So let's write an inequality. And remember, you want to write your inequality using the original numbers. We've changed them with the denominator so it's easier for us to tell what they are, but still when we write our answers, we need to write them with the original problem. So we're going to say -1 and 7/16 is greater than -1 and 5/8. And then we have -1 and 5/8 is less than -1 and 7/16. These would be our two inequalities there. Okay, so now, back to the beginning somehow. All right, here we go. Example 3. Write the following numbers in increasing order. Graph them on a number line. Well, if I graph them on a number line, okay, it's going to be very easy for me to see these in increasing order because they will already be in increasing order. Remember, from left to right, increasing means from smallest to biggest. So if I graph them, they're already going to appear from smallest to biggest. So let's go ahead and do that. Now, my suggestion to you is when you're dealing with numbers like this, have them all the same. So they're either all decimals or whole numbers, or they're either all fractions and whole numbers. So what would be the easiest thing for me to do? Decimals. Because I only have one fraction. If I changed them to fractions, I would have to change 2, which they'd be easy, but still. So what is 1/3 as a decimal? Zachary? 0.3 repeating. Okay, or 0.33. All right, so let's place these on the number line. -1.5, so I go to the -1, past it, and a half. Then 0.3, which is a positive number, so I'm going to go from the 0 and I'm going to go over about 1/3. Which actually I'm going to write it as a fraction so I know in my original answer it needs to be a fraction. -3, so I go over to -3. 2.5, positive number, so I go over to 2. And then halfway between the 2 and the 3. 0. And then -1. So look what this number line has done for us. It has already written out our answers in increasing order. So all I got to do is copy it down. -3, negative 1.5, negative 1, 0, 1/3, because I want to write it as the original, and 2.5 is increasing order. So now we're kind of done with number lines. They've served their purpose. They've helped us find the order of numbers and things like that. Gives us a physical way to see where numbers lie. Okay, now what they want us to do is we're going to talk about opposite numbers. Now, opposite numbers are where the number lies on the number line. So if they were to give me 1, okay, we would find 1 on the opposite side of the number line, 0 being our middle, okay, and it would be negative 1. So the opposite of positive 1 is negative 1. That means the opposite of negative 5 is positive 5. Okay, so that's all the opposite is. So what is the opposite of positive 1/2? Cole? Negative 1/2. What is the opposite of negative 3? William? Positive 3. What's the opposite of 2.5? Nishan? Negative 2.5. What's the opposite of 0? Vincent? 0. There is no opposite of 0 because 0 is neither positive nor negative. So it's just 0. Okay? Absolute value. Stay with me for a second. And I'm going to read this sentence. The absolute value of a number is never negative. Okay? I'm going to say it again. The absolute value of a number is never negative. The absolute value is never negative. So what these things are right here around the 1/2, these are what I call absolute value bars. What they tell me is the value of the number inside of the bars without any sort of sign. So it would be like our true value. So the absolute value of 1/2 is positive 1/2. These absolute value bars, what you need to remember about them is they are not parentheses, they are not brackets, okay? They do not act as those. They simply tell us whatever is inside of those absolute value bars, the answer is going to be positive. Okay? Here's one other thing now. Stay with me as I say this. The absolute value of a number is never negative. However, there's always an exception. That does not mean our answer is never negative. Does everybody hear that? The absolute value of a number is never negative. However, that does not mean that our answer is never negative. So, before we get into that, let's do a few more of these absolute values. So, if the absolute value of 1/2 is positive 1/2, what's the absolute value of negative 2? Cole?
2.
Positive 2. What's the absolute value of 6? Zachary?
Positive 6.
Positive 6. What's the absolute value of negative 10? William? Positive 10. Let's go back to that statement. The absolute value of a number is never negative. Well, there we go. We just proved that right here. However, that does not mean our answer is never negative. This is what I mean by that statement. Okay? Look at this next problem right here. Where is the negative sign? Mary?
On the outside.
On the outside of the absolute value bars. That means that negative does not have to follow by the rules of absolute value because it's not inside of the bars. Only whatever's inside of the bars follows by those rules, okay? Whenever I have a negative sign on the outside of the absolute value bars, it has to be carried into my answer. Has to be. It never goes away. It always appears in my answer. Then I just ask myself, well, what's the absolute value of 3? 3. The absolute value isn't negative, but my answer is negative. Does everybody see that? Anytime there is a negative on the outside, it has to be carried into your answers. I still ask the question, what's the absolute value of 3? And I get 3. but that negative is still there, and it has to be in my answer. So let's look at the next one. Here's the mistake people make, is they look at these absolute value bars and they say, oh, they're just like parentheses, so a double negative means a positive. No. What did I say at the beginning? Absolute value bars are not parentheses, and they are not brackets, and they do not act like them. Okay? So this means anytime I see a negative sign on the outside of the absolute value bars, where does it have to go? To the answer. What's the absolute value of negative 8? Positive 8. But my answer is negative 8. Okay? Does that make sense? Okay, now what they want us to do is they want us to find the value of x. Now, they are not asking us to find the absolute value. They've actually already given that to me. They told me that the absolute value is 7. All right? What they want me to find out is what numbers could I plug into the absolute value bars that would give me an answer of 7. Guess how many numbers you can plug in for x? 2. The reason why is, watch this. Okay, if I know the answer is 7, the absolute value is 7. So what if I were to plug in a positive 7? What's the absolute value of positive 7? 7. So we know, okay, x can be 7. What if I were to plug in a negative 7? What's the absolute value of negative 7? 7. So that would work too. So my answer could be positive 7 and negative 7. All right, skipping to the third problem in this. Skipping to the third problem, okay? We're going to come back to the second one, but in just a second. What numbers could I plug in for x that would give me an absolute value of 3/4? Zachary?
0.75 and negative 0.75.
Okay. Zachary said something that needs to be addressed. He said 0.75 and negative 0.75. What is the absolute value right here? 3/4. That's what x needs to look like. It needs to look like the answer. Now, that's not wrong, 0.75 and negative 0.75. Those are technically 3/4. But unless they give it to you in a decimal, your answer should never be a decimal. So x needs to be positive 3/4 and negative 3/4. All right, now let's look at the middle one. Let's go back to the middle here. This is tricky. How do I ever get a negative answer? Mary?
By having a negative on the outside.
Very good. By having a negative on the outside of the absolute value bars. Do I have a negative on the outside of the absolute value bars? No. So is there any number in the whole world that I can plug in for x and get a negative number? No. If I plug in 5, the absolute value of 5 is 5. If I plug in negative 5, the absolute value of negative 5 is positive 5. So this one is no solution. Because there is no solution. There's nothing I can plug in for x to give me an absolute value of negative 5. Not possible. All right, this last example is for my honors classes only. And they're going to give us a statement, and they want us to tell whether the statement is true or false. And if it is false, give a counterexample. All that means is prove to me that it's false by an actual math problem. So, for instance, like if I were to say negative 1 is the largest number in all the world. Well, you would say false because 2 is greater than negative 1. Okay? That's a counterexample. So let's read this. The opposite of a number is always negative. True or false, Cole?
False.
False. And give me a counterexample to prove that.
The opposite of negative 7 is positive 7.
Yes. The opposite of negative 7 is positive 7. There you go. Okay? The next one. The absolute value of a number is never negative. True or false, Vincent?
False. Because that example that you just did was like a negative.
Which example that I just did?
Or not the last step, but the one before that where there was a negative sign on the outside.
Okay, but when there's a negative sign on the outside, is that the absolute value? No. Remember that big red sentence that was at the top of the absolute value? So the absolute value of a number is never negative. Is that true? Yes. Because we're not talking about if there's a negative on the outside. It doesn't say that. It just says the absolute value. So this is true. Okay?